This is an oscillator problem. So the mechanical energy of the system, right, the formula for mechanical energy is that it's kinetic energy plus potential energy. So that's going to be 1/2 mv squared plus 1/2 kx squared for the spring. The easiest way to calculate mechanical energy is to look at one of the critical points. For example, when x equals 0, the mechanical energy is 1/2 mv squared, and that's when v is equal to its maximum velocity. When v equals 0, it's at its maximum elongation, so E equals 1/2 kx squared, where x is maximum, and so we can call that 1/2 ka squared, where a is the amplitude. Well, we're given the amplitude here. It's 75 centimeters, right? So 0.75 squared, so this is just 93 joules. Right? So that first part is easy enough. Okay, part B. This is going to require some sort of algebraic trickery. At what distance from the spring's equilibrium point is the velocity of the mass equal to half its maximum velocity? Okay, well, so from up here, right, if we look at this equation, we have that when x equals 0, when x equals 0, v is equal to v max, right? So at that time, 1/2 mv max squared is equal to the mechanical energy. But we also know that the mechanical energy is equal to 1/2 ka squared, right? So we can write 1/2 mv max squared is equal to 1/2 ka squared. And that gives us, if we solve for v max, that gives us v max is equal to the square root of k over m times a squared. So we're going to let v equal 1/2 of that. Okay. Now, on your formula sheet, we have a more generic formula, right, that starts with, well, at any general time, 1/2 mv squared plus 1/2 kx squared is equal to the mechanical energy, which is 1/2 ka squared. And from that, we have the formula v is equal to the square root of k over m times a squared minus x squared. So we are going to take these two guys and set them equal to each other, right? This is the velocity at the specific time we're looking for. We want to know when the velocity is equal to half the maximum. And this is a general equation for the velocity at any time. So we're going to set these equal to each other and find x. All right? So 1/2 times the square root of k over m a squared is equal to the square root of k over m a squared minus x squared. So the first step is to square both sides, and we get 1/4 times k over m a squared is equal to k over m a squared minus x squared. K over m appears on both sides, so we can cancel it out. So I'm left with 1/4 a squared is equal to a squared minus x squared. And if I group my like terms, I get x squared is equal to 3/4 a squared, or x is equal to the square root of 3/4 times a, which is 0.866 a. And that is 0.65 meters. So there's the answer.